Welcome everyone, Mozilla Firefox Club. Welcome you to the series Ferns of ML. So let us start today's discussion by discussing first about decision tree. So in that first we will be discussing about decision tree regression. So let us have a look that what is decision tree. So decision tree is one of the highly recommended ML algorithm for both linear data as well as non-linear data. We have discussed in the previous series that uh, what is linear data and what is non-linear data. So if a data can be separable using a straight line, or if the model can be fit using a straight line, then it is a linear data, and if it is not able to fit using a straight line, then it is a non-linear data. So the decision tree can fit for both the linear and non-linear data. So it is one of the highly recommended algorithm. So let's start with what is decision tree in technical terms. So decision tree is a flowchart like tree structure where each internal node it denotes a test on an attribute, and then each branch it represents an outcome of the test. And each leaf node, which is also known as a terminal node, it holds a class label. So this definition says that just like natural trees, decision trees works in the same way. There is a root node, and then the root node is connected to several internal nodes, and at last there is a leaf node which holds the label of the class. Now here the internal node will act like a test case. Suppose if there is a value, let's say x, and which is going from root node to the internal test cases, and if x satisfies any of the test cases, then it will reach the another test case. So the test case which is there, it is known as the internal nodes over here, and like that there are several internal test cases until the outcome reaches the leaf node, which will be holding a label known as class label, and the prediction will be made. So let us move to the next topic, that is what is cart. So cart is basically defined as the classification and regression trees. So it is like there are both types of algorithms, which are decision tree classification and decision tree regression. So let us now look at the decision tree flowchart. So here it is explained that how does a decision tree flowchart works. So first of all, there is a root node, and then a root node is connected to several internal nodes. Like these are the internal nodes. And after that, there can be even a single internal node, or there can be a multiple internal node. So you can see a root node, and the internal node it will here act as a test case, and it has two possibilities, which is either yes or no. So if the possibility is yes, then we go to the next case. So here the possibility is yes. So from the root node it went to the internal node, which is x2 less than 200. And if it satisfies any of the condition, like if the yes is satisfied, then 300.5 the leaf node it will reach, and the class label is 300.5 over here. So here, as you can see, here is only one internal node. But if we go to the possibility no, there are multiple internal test cases which it should pass. That is, there are multiple internal nodes, as you can see. And what the final result would be there, that class label it will hold. So this is how the decision tree works in the backend. Then let's understand the working of the decision tree more deeply. So here you can see that uh, there is a plot on the left hand side, which is again a non-linear data plot, as the model it can't be fit using a single line. So we can say that it is a non-linear plot. So in this case, what our ML algorithm, which is decision tree, what it does after it is applied, it is further divided into random splits. So the decision tree divides the data into random splits. So here you can see that the data is divided into five splits, which are five reasons over here. And then for the each split, that is the reason, the average will be calculated, and whatever the average which will be calculated, it will be assigned a value. And if you have a new value which is corresponding to any of the averages, then it will classify them as the following data point, that it belongs to a particular region or a label. So now we understood the backend of the decision tree. It will split the data in random splits, and each split will be given by its label by calculating the average. So after that, let us see that how to implement the decision tree regression model in our code. So we will be importing the decision tree regressor class from the module which is sklearn.tree. So here the sklearn.tree, it contains like two types of classes, which is decision tree classifier and decision tree regressor. So from this module we are importing here decision tree regressor for the decision tree regression model. Then we will be instantiating or making an object of the class which we have imported, and here we are creating an object which is regressor over here, and then a parameter is passed over here which is random state is equals to 0. So here we are passing the random state is equals to 0. So the random state, it could be any value. Like here we are taking it 0. Many people, they also do like tend to take it as 42. So it depends on you what you want to take the value. So random state, it is just a value, so that every time you run the model, the randomization of the data, it always remains the same, so that you get the correct output and there is no like overfitting, or there the model accuracy is not decreased. So for that, the random state is used for randomization. Then again the same thing we'll be doing as we learned in the last session, that again we have to train the data set. So for training we'll be using the dot fit function, and after, like, we have to split our data into train and test. So we have, after splitting the data into training and testing data set, we are passing both the independent parameter and both the independent variable and the dependent variable to train our model. After a model gets trained, we have to predict the outcome. So to predict it, we have to use dot predict function. So after that, we will be using the predict function to predict the result, and here the x test will be passed, that is the independent variable of our testing data. So let's then look at the advantages and the disadvantages of the linear tree regression. So first, the advantage is that as compared to the other algorithms, decision tree, it requires less effort for data preparation during the pre-processing. So in the previous session, that which was the first projection, we have learned about the data pre-processing methods. So as you can see that the decision tree, it requires very less data preparation, so it is very useful and handy for us, and it will reduce a lot of time. So this is the first advantage. Then the second advantage is that a decision tree, it doesn't require the scaling of data as well. So this is also the scaling, which is also a part of data pre-processing. So which means to standardize our data or to normalize our data into the same range. So when we are normalizing our data in the same range, like for all the columns of the data set, it would be very helpful because our data would be normalized. Then the third advantage is that the missing values in the data does not affect the process of building decision tree to any considerable extent. So like if you forget any like missing value to handle it, it won't be any problem in decision tree because it won't get affected, the accuracy won't be affected here. Then coming to the disadvantages, a small change in the data can cause a large change in the structure of the decision tree, which can cause instability. So as we have already seen that the decision tree, it uses the splitting of data. So we saw that it splits the data into many regions. So there is a small change in the data that it is like splitted into different regions. So like if it is that it will cause the instability of the decision tree. So the training model which we have, its accuracy would be affected. So we should be careful about that, and this is one of the disadvantage of decision tree. Then the decision tree often involves higher time to train the model, as we have seen that decision tree flowchart. So we can see that there are multiple internal nodes and multiple cases before we reach the final leaf node. Then the time required for that calculation will also be much. So it can take a higher time to train the model, which is the second disadvantage. Then the third disadvantage for using the decision tree algorithm in our ML model is that it can sometimes cause calculation to go far more complex. So the complexity increases as compared to other algorithms such as linear regression or polynomial regression. So this is the other disadvantage of decision tree. So then let us move to the decision tree classification. So the definition would remain the same because it's also a decision tree only. So it is even a flowchart with internal nodes, which represents the test cases, and finally there would be a leaf node. Now let us look at the workflow or a flow chart of decision tree classification. So in decision tree classification, we also have the same definition because it is also a decision tree, but it can be used both for regression and classification. Decision tree is a flowchart shaped like a tree where every internal node denotes a check on an attribute. So classification rules, they are followed from the root node to the leaf node. So let us discuss some of the terms over here. So what is a root node? So root node, it represents the entire population of the data set, which can be further divided into two or more equivalents. Then a decision node is something which is a sub node, or we can say that both the root node and internal nodes, they are decision nodes as they are making any decision. So this is what a decision node. Then the leaf node is a node which can't be further splitted. It would be the final outcome. So here, no, yes, it is the leaf node, and outlook, humidity, these are the decision nodes. So here it is also important to one more term, which is pruning. So pruning is the process of removing the subnodes from the decision tree. So basically, if you prune this part, this tree, the subtree, the part of the whole tree which is subtree would be removed. And as we have already learned, like what is a parent or a child node, we already know about it. So here we could see that uh, the decision tree, it usually follows if then else condition. So it follows a rule which is known as if then else, and due to which it's very simple or it's easy to program it. Look, the programmatic structure would be easy. So decision tree are best for characterization problem where attributes or features, they are systematically checked to determine a final category. So we can, here it is about like predicting if the match would be played or not according to the weather conditions. So it is all about the weather forecasting over here. So the given diagram illustrates a decision tree. You can see that the node represents an attribute and a branch of each node represents the outcome of the node, which is either rainy, cloudy, or sunny. And finally the leaves, it will represent the final decision which will be made, like whether the match is going to happen or not. So decision tree helps in finding these conditions. So here you could see that if the like outcome, the outlook attribute, if it's rainy and if the wind is strong, then the possibility to play is 0, and don't play is 2. So the match won't be played if the outlook, which is if the conditions are rainy and wind is strong. So if it is cloudy, then it is no, like it's only satisfying one internal test case. So yes, the match would be played if the condition is cloudy. When it comes to sunny, it should pass one more internal test case, which is either the humidity is high or normal. If it is high, then the match won't be played because the possibility is over here. You can see the to play it is 0 and don't play is 3, and when it is normal, then we can play the match. So like this is what decision tree works over here. Then let us like try to find like what will be the best attribute for classification. So the best attribute for the classification, it can be found in two ways, which is information gain. We can calculate the information gain of the each node using an entropy, and then the attribute whose entropy or the information gain will be the highest, we will be taking it as the root node. So here, after calculating the outlook, humidity, wind, and temperature, all these nodes information gain value, when we are calculating it, we are seeing that the highest value is 0.246 as compared to these values which are less. So as this value of information gain of outlook node is the highest, so we will be considering this as the root node, and like this we will be finding the information gain, keep on finding it, and then we'll be finding the test case and the root node, everything, and then the decision tree would be calculated. So here it's what written, which I explained, that the attribute with the highest information gain is selected as a splitting attribute. Then let us see some of the applications of decision tree. So it's not that these are only the applications of decision tree, but it has many different applications. So but yeah, these are some of the important applications. So the decision tree could also be used in biomedical engineering. So biomedical engineering is integrating the bio with the engineering. So let's understand an example. Like, you must have heard of a sensor which is attached to a wrist to open or lock the door. So in that, the condition is when to open the door and when to close the door, that is trained using the ML algorithm, and in that also usually decision tree is used. Then comes the medicine. Decision tree could also be used in diagnosis and psychiatric problems to predict. And then in astronomy also it can be used, so in the outer space to classify like whether it is a celestial body or planets, stars, everything, it could be used in astronomy also. Then for financial analysis to predict the stock market price or the profit or loss, the decision tree algorithm can be used. Then for manufacturing and production, which is to classify whether the product is like defective or not, whether it's a good product or bad product, so that the customer doesn't get a bad product or a defective product. So now let us understand how to implement classification model in our code. So the first thing is that from the module which I told, that sklearn.tree, it contains both regressor and classifier. As it is a decision tree classification model, we will be importing decision tree classifier over here, and then it would be again made an object. This class, we will be creating an object of it which is classifier, and the criteria which we are using is entropy. So the default value of criteria is Gini, but here we are using entropy because entropy, it doesn't cause or like it usually normalize the data. So for that we prefer to use entropy, and here the random state is again passed as 0. Then we are training the model using the dot fit function, and again the training data set is passed, and then we are predicting our model by passing the testing data set. So let us even understand like the overfitting which occurs in decision tree. So even there are possibility that overfitting can occur in decision tree. So overfitting, it occurs when the learning algorithm, it continues to develop hypotheses that reduce the training data set error at the cost of an increased test set error. So like you can say that the decision tree algorithm, it continues to split on an attribute till it either classifies all the data points or there are no attributes to further split. So as a result, its reliability, the decision tree will act very well on the training data at an expense or at the cost of the accuracy which will be disturbed of the testing data set. So there won't be entire distribution of data, and the accuracy would be like affected as it overtrains on the training data set and learns from the bias and the outliers. So how to avoid that in decision tree? There are usually two approaches to avoid it. So the first approach is either allow the tree to grow until it overfits and then you prune it. So we discussed that only about pruning, is that to remove a specific subtree or subnode from the tree. Then the second approach could be to prevent the tree from growing too deep by stopping it before it perfectly classifies the training data. So this was all about the decision tree. Then let us move to the random forest. So as the term random forest, you would be like familiar that it would be a combination of different decision trees. So before moving to random forest, it is important to learn about ensemble learning. So let's learn about ensemble learning. So basically, what is ensemble learning? So ensemble learning in general is a model that make prediction based on the number of different models. So, in by combining the individual models, the ensemble model it tends to be more flexible, which is less bias. So, less bias means the difference between the training data set and the testing data set will be less, and it would be like less data sensitive, which is that it would be less variance. So the random forest it uses a decision tree as its backend and it uses a number of decision trees. So there are individual trees model which can be combined to form a single random forest model. So the model will be more flexible as because there is an involvement of many decision trees and our accuracy would be more, and it has less variance towards the data, so the prediction can be accurate, and the predicted and the actual output it will have less error, that is it will be having less bias. So random forest is also a model of ensemble learning only. So in this, there are two terms which are bagging and boosting. So let's first see what is bagging. So bagging is basically training a bunch of individual models in a parallel way, and each model is trained by a random subset of data. So it means that, what does it mean? That in bagging we use several decision trees as the backend in random forest for prediction, and but in all that the trees which will be which we are using as a combination, they are used in a parallel way, and after they have completed their task we will combine all the outcomes of the trees and they will form a single output for the random forest. And in boosting, what we will be doing is we will be training a bunch of individual models in a sequential way. So each individual model it learns from the mistakes made by the previous model. So in boosting, the model is trained in a sequential way, which means that the first model is trained with a particular data, and after that the output is drawn, and after we have we got the output, we will calculate the errors from it and change the data set accordingly. But in bagging, what happens, the entire data set it is passed to the different decision trees in a parallel way, but here like there is a distribution of particular data set into different subcategories, and it would be given for training to different decision trees. But in boosting, what we will be doing is, for a particular data set we will be calculating the errors and we will be changing that data set accordingly, so that the next model which we will predict it will have a good value and better accuracy than the first one, and the process it continues till we get the highest accuracy. So this is how the bagging and boosting works, and they are different from each other. So for more understanding, let us see the image which describes the two topic more clearly. The first one, which is bagging, as you can see over here, as I told, the data is subdivided into different subsets as subset 1, subset 2 to n subsets. And then the data, um, it is basically trained by different decision tree, so that after we get the result of each decision tree we'll be combining all the results and then generating the model according to the voting, which will be the majority one. But in boosting, as you can see, that the whole data set it is passed to a single decision tree, and after it learns from the mistake the data set is adjusted and then it is passed to the next decision tree, and the same process is repeated until to the nth decision tree, as you can see over here, where we get the highest accuracy. So here the data doesn't split into different subsets, but a whole data set it is passed to a single decision tree only, and after we get the model we try to alter the data set so that the next time it predicts the value, it the accuracy should be different. So here you can see that it is written the adjusted data set 1. So after training we adjust the data set, and like that it follows till we get the nth data set which will be having the highest accuracy. So now the question comes that what does the random forest regression uses? Either it is like bagging or boosting. So let's understand what does it use. So random, like it basically it is referred to as a forest of trees, and hence the name is random forest. The term random, it is basically due to the fact that the algorithm is a forest of randomly created decision trees. So from the image you can see that random forest, it uses the bagging technique. As you can see that the data is divided into different subsets, so and then it is passed in a parallel way, so we can say that it uses the bagging technique. So for this, the entire data, it is split into small data sets, and each decision tree is trained with a particular different data set, and the outcome of each decision tree is then combined, and we can combine the data using the mean, median, or mode, any of the three, and a final output of the random forest will be getting according to the majority of voting. So we use the majority vote of each candidate in the test case to get a final result over here. So this is how the random forest regression works, and it uses the technique which is known as bagging. Now let us understand that how to implement random forest model in our code. So first we have to use random forest regressor class from the random forest, like for the random forest regression model from the sklearn.ensemble module. So after importing the class, we have to instantiate with our object, so that the regressor here is our object, and the we are creating an object for this class random forest regressor, and then n estimators is equals to 10, which is passed. So this is also a parameter which is passed, which we will be talking about it in detail. And then the random state is equals to 0, which is used for randomization, so that every time we train our model, the data remains the same, and we don't get different output every time when we try to train our model. After that, we follow the same thing, that we use dot fit method to to train our model, and the x independent variable and dependent variable of training data set is passed. And here you can see that we are reshaping it to -1 or 1, so you could like do it without reshaping also, but here it is done by using dot reshape function, which usually like changes the shape of the data set. And then we can use dot predict function to predict our result, and that result is stored in the ypred variable. Then, as I told, we will be discussing about the parameter, which is n estimator. So now let us discuss about n estimators. So you can see that on the second line of code, we have like after creating an object, we have passed over here the n estimator parameters. So let us understand what is n estimator. So n estimator basically represents the number of trees in the forest. Usually if the value of n estimator is higher, which means that there are more number of trees, it is better for the data. However, adding a lot number of trees, like if more decision trees are used, it can also slow down the training process considerably. Therefore we need a parameter to search or to find a sweet spot. So from this, what we can understand that more the number of trees our model will use, like it would be effective. But if a large number of trees will be used, like excess number of trees are used, it can also make our model slower and slower. So we have to use different values of n estimators, which is basically the number of different decision trees to use, and see how the result is coming for each, like each value after passing. And then we should fix the value who gives the best accuracy, that value will be fixed. So this is almost all about an estimator. Then let us look at the advantages and disadvantages of the random forest regression. So coming to the advantages, the random forest, it uses both classification as well as regression problems. It can solve both regression and classification problems. Then the second advantage is that the random forest, it works well with both categorical and continuous variables. So the categorical values, let us say that multiple categories are present, so we have to predict the different categories of fruits such as mango, guava or grapes. So like for that it can be also used, and even for the continuous variables it can use. Suppose we have to predict the price of the house. Then the third advantage of random forest is that it can automatically handle the missing values. So if the missing values are also present, then it would be automatically handled. So it is handy because we shouldn't consider, like we shouldn't take more stress about the missing values. So one more step of data pre-processing is reduced even in random forest, as we saw the same is applicable for the decision tree also, that even the decision tree also handles the missing values. So the random forest is usually robust to outliers, and it can handle them automatically. So what are outliers? So outliers are the data points which are very rare in our data set and which show very unusual characteristics. Suppose like if other data point is present, then the random forest can easily handle that outliers or that points which are very rare to our data set. Now coming to its disadvantages. So the disadvantage is that the random forest, it creates a lot of trees, unlike only one tree, which was in the case of decision tree. As we saw, it uses only one tree, and then it combines the outputs. By default it creates 100 trees in the Python sklearn library. So to do so, this algorithm, it requires more computational power and resources. So this is the advantage, that it has a very high complexity. But on the other hand, decision tree, as it uses only one tree, and random forest, it uses a combination of trees. So automatically the complexity will increase for that, and the decision tree, it will automatically take less computational resources. So coming to the next disadvantage, which is longer training period. Random forest, it requires much time to train as compared to different like decision tree, as it generates a lot of trees and make a decision on the majority of votes. So it can take a long time for training a model because it's very complex and it is a collection of different decision trees. Then let us take a look on the random forest classification. So the definition would remain the same, that again it uses the same technique, and then again the voting will be used. Then let us look at the working of the random forest algorithm. So the step one is that we should start with selecting the random samples from the data set. We should be selecting the samples on a random from the data set which we take into consideration, and then we should construct a decision tree for each sample that we have taken into consideration, and then we should like get the prediction result from each decision tree. So particular subset of data will be applied on a particular decision tree, and then we will be combining all the decision trees output and then making the results. So the step 3 would be the same, that the voting will be performed for every predicted result. So you get many results from each decision tree. So how to select the best result or the final outcome, it would be done using the voting technique, where every predicted result would be chosen from the majority voting, which is again written over here, the same thing, that it selects the most voted prediction result as the final prediction result. Then let us see how to implement the random forest classification model. Again, from the same module, which is sklearn.ensemble, we should import random forest classifier, and then we should create an object and pass. Here we are passing n estimators as 50, so it means that we are considering 50 different decision trees to build a random forest model, and then we are training it and then predicting it using dot fit and dot predict function. Now let us look at the third algorithm, which is a naive Bayes algorithm. So naive Bayes, it basically comes to our mind is naive Bayes theorem. So let us see what is naive Bayes algorithm first. Naive Bayes, it is basically a mathematical equation, as you can see here, that P of C by X is equals to P of X by C, into P of C divided by P of X. So basically, it is a probability thing which uses a naive Bayes theorem, which we have already learned in class 12th. So it which comes under probability. So let us understand the definition of naive Bayes algorithm. It is basically a classification technique which is based on the Bayes theorem. As I said, it is based on Bayes theorem, which is a theorem of probability, and then it makes an assumption of independence among predictors. In simple terms, the naive Bayes classifier assumes that the presence of a particular feature in a class it is unrelated to the presence of any other feature. So, what this definition says that we want to convey that we know different features that are connected with each other, or we can say there is dependency on each other. But the assumption of naive Bayes algorithm is that all the features or the predictors which are taking into consideration it will be independent. So the one column or the one attribute of a particular data set it won't be dependent or it will be independent on the other column or the other attribute. It means that there should not be any relation between the features in the data set. So this is the assumption which the naive Bayes algorithm makes. So here you can see that P of C by X, which is like we already know the probability of C, and we know that the event X has already occurred. It means this, like we have to find the P of C by X in that we already know the probability of C and we know that the X event has already occurred. So this probability is known as posterior probability, and probability is also known as likelihood. Then P of X is the predictor prior probability, and P of C will be the class prior probability. Now let us see how to implement naive Bayes in our code. So we will be using the module which is sklearn.naive Bayes, and we will be importing the Gaussian naive Bayes algorithm, and then we will be creating an object named model is equals to Gaussian NB, and then we will be using dot fit method to train the model by passing the independent variable of the training data set. Then let us have a look like about the advantages and the disadvantages of the naive Bayes algorithm. So the first advantage is that the naive Bayes algorithm is easy and for and like fast to predict the class of the test data set. So let us take a scenario that you are working in a company and your project leader it like he has told you and has given you a data set, and you need to make a model as fast as you can with the best accuracy score. So at that time you can take the naive Bayes algorithm into the consideration because of the best thing that it is very fast and it can also work well on the large training data set. Then even it we should also know one more point about it, that it also performs well in multi-class prediction. Suppose you want to predict whether a person has survived or not in the Titanic. So it basically comes under binary classification because either the person would have survived or not. So naive Bayes can be used for that also, and also for multi-class prediction where we have more than two classes. Then the second advantage is that when the assumption of independence holds, a naive Bayes classifier it performs a better compared to other models like logistic regression, and you need a less training data. So when the assumption of independence holds, a naive Bayes classifier it will perform the best. Then that only would become our disadvantage also, because you can see that the many real world data sets it is not possible to have all the data sets which whose attributes are independent of each other. So as it is like difficult to find these kinds of data sets, so this is also again a limitation of naive Bayes, which makes the assumption of independent predictors, which is written over here, that again in the real life data set it is almost impossible to get a set of predictors which are completely independent. Then the first disadvantage which is written over here is that if you have a categorical value which has a category in the test data set which are not observed in the training data set, then you can get a model which will assign zero probability, and it will be unable to make a prediction, which is also known as zero frequency. So let us understand with an example that suppose you want to classify the gender as male or female and you have trained your model on the data set. But while testing your model, suppose the third category pops out. Like it, let us say that it is like not defined or anything. Then what the naive bias does is the new category or the new value which has popped out, it will assign that variable as zero, and it does not make any prediction on it. And this phenomena is again called as zero frequency, as it is assigning that label as zero. And so to solve this phenomena, we have defined something which is known as smoothing technique, which is known as Laplace estimation. So we will be using Laplace estimation to handle the problem which is zero frequency. Now coming to the applications of naive bias, which is real-time prediction. So as I told you that naive bias is very fast algorithm and it is very easy to work on huge data sets. So it is mostly preferable for real-time prediction. Then the third application is that it can be used for text classification, spam filtering, or sentiment analysis. So the naive Bayes algorithm, it always works well on textual data. Either we are filtering the spam emails, say in Gmail, or we are classifying a particular text as positive or negative. And also in sentiment analysis, the base algorithm, naive Bayes algorithm, it will perform well on such applications. Then the third application comes is random is recommendation system, whether it is to recommend a movie to the user, or let us say whether to recommend a product to a customer. Naive bias is used with a collaborative filtering to filter out the data. So naive bias, it is basically used with collaborative filtering which will filter out the data. It can also be used for multi-class prediction, and it also always gives a good accuracy on it, as we have seen that and the advantage of naive bias also. Now let us work on the hands-on project on decision tree. So now let us work on the hands-on project, which would be to classify the iris species. So to classify the iris species, we will be using the decision tree algorithm. Let me name it decision tree classification model. So we'll be using this. So first, our problem statement is to classify the different classes of iris species, whether it could be Virginica, versicolor, like that we have to classify it. So first we will be importing all the necessary libraries which we will be requiring. So first we'll import all the necessary libraries. And to import we will be for like this data set we will be directly using online, so we can as it is present already in the sklearn library, we can use sklearn.datasets for it, and from that we will be importing the load iris dataset. After that we will be using or importing pandas to here there is no need of pandas because we are loading it online. We can import numpy because we have to perform array operations on the loaded data set, so the numpy would be needed. Then we have to import matplotlib to find out what will be the best suitable value by plotting the graph. So I'm like importing the matplotlib.pyplot as plt. Then let me load the data set in a variable. So let me name the variable as data set, which is equals to load iris of. Then we will be summarizing our data set. And to summarize the data set, let us print it. So first we will be using the data set which we have initialized, and we will be using the dot data function. It will give us all the independent variables or the features which we are considering for making this model. And after that we can also use dataset dot target. So dot target, it will give us the output variables, like the independent variable who's like what we want to predict. That would be given by using dataset dot target. And then even we can print the shape of it. So let me print the shape for dataset dot shape. Then here we should also pass it for which variable. So for the target, always we know that there would only be one column, so no need to print that, but we will see how many like independent variables are present. So here we can see that there are particularly four independent variables, which are petal height, petal width, sepal height, and sepal width. After that, we will be splitting our data set into train and test, which we have already seen in the previous session also, that we should split our data set into train and test. And for that we have to import some class from sklearn, which is known as model selection. So from sklearn dot model selection, we will be importing test train test split. Then we will be assigning the variables to it, like xtrain, xtest, ytrain, and then ytest. And again we will be using that function which we have imported from sklearn.model selection, which is train test split. And in that we will be passing the parameters, which would be x and y, which are independent and dependent variables. Then we should define the test size of it. So let me define the testing size as 25%. So we'll be writing 0.25 for it. And then we can use the random state for randomization, and for that we will be setting it as 0. Okay, we are getting an error for this. So the error, so we have imported it. Okay, the enter is missing. We should assign it to a variable. Okay, so here let me write it, and the panda, like we will be using the data frame for it. So let me initialize it, the x variable. It would be like pd dot data frame. Data frame is basically a two-dimensional data structure which will store the data in the forms of tables, which will be data set dot data, and again the columns, which will be equal to data set dot feature names. This is directly a function present over here, and then let me print the x value for this. So it gives gave the data in the form of data frame. And again, if we run this part now, the x value would be defined, but the y value won't be defined. So we will also be defining the y value over here. So let me store that variable. For the target variable, I will store it in y. So y will be equal to dataset dot target. Okay, then if I want to print the value of y, I will get the three classes, which will be 0, 1, and 2. As the iris dataset, it will be defined as setosa, versicolor, and virginica. So for setosa, it will be 0, for virginica, it will be 1, and for versicolor, it will be 2. Now if we run this part, hopefully we won't get any error. Yeah. So after this, we have done the splitting and testing successfully. Then we will be finding the best, like the best depth value. So for that, we will be plotting the graph for it. So for that, let me store, or we'll be plotting the depth versus the accuracy graph. So for that to store it in a data structure, I'm using list over here named as accuracy, and then from sk learn.tree, we should import decision tree classifier, as we are using decision tree classification model. So we will be using decision tree classifier, and then again we will be importing matrix also to import the accuracy score, so that we can get the accuracy score for each depth which we are taking. So for that, we are using sklearn.matrix, the module, to import the accuracy score. So we will be importing the accuracy score, and again to plot it, we will be using the matplotlib library, which we have imported in the first line only. So for I is equals, for I in range, let us take any range. So let me take the range as 1 to 10. So for the range 1 to 10, we have to store a variable model which will be calculating or taking the max depth and calculating the accuracy. So for that, we will be using decision tree classifier, which we have imported. And then we will be using the max depth variable which will be assigned as I. So here what will happen, for I in range we are learning like running a loop, so it will take the variable from 1 to 9, it won't include 10, it will be taking from 1 to 9, and it will give the accuracy for each particular data which will be stored again in the list, and we will be plotting the plot. Again, for the issue of randomization, let me initialize the random state will be equal to 0. Then we will be training our model to get the accuracy. First, we should train our model. For that, we will be using the dot fit function and passing the x train and y train. And then we should initialize a variable to store the prediction. Let me initialize the variable as spread. And then we will be using dot predict to again predict a model. And here we'll be passing the only the x, the independent variables of the testing data set. Again, we should store the accuracy for it, so let me initialize for that accuracy score variable for it, and then we will be using the accuracy score which we have imported from sklearn.matrix, and we will be passing over here the y test, which will be the testing the dependent variable of the testing data set, and the prediction which we have made, which is already, this would be already present in our data set, and this is what we are calculating over here using dot predict function. Then our next step would be to append that in the list which we have created in the first line. So the accuracy dot append of score, it would be appended in that list. Now let us plot a variable, like we should plot a graph to understand like which value we should take. So plt, which we have like we have imported the matplotlib, and fixed size would be used to give the size of the plot which we want. I'm passing over here 12,6. Then plot function to plot the graph, and the range would be given as 1 to 10 as we have taken over here. Then we will be also passing the accuracy variable. The accuracy variable would be passed, and now we should define the color for our plot. So let me define the color as red. And then the line style for that graph. So let me keep the line style as dashed. And then the marker which we will be using will be circle. So for circle, we should use O, and we will be writing over here O. And then the face color, marker face color, what should be the color present inside the circle? Let me keep as blue, as we have kept that only for the last session also. So marker face color will be equal to blue. And the marker size, let me keep it as 10. Then let me initialize the title of the plot. So plt dot title, and what the plot we are plotting, we are finding the best depth value. So let me plot it as finding best max depth. After we have named our graph, we should name our x label and y label for that. So for that we will be using x label and y label function. So plt dot x label of spread, it will be the prediction, and the score would be in the y plot. So As we can see, we got the plot between the score and the prediction. So here we can see, for when our value for the maximum depth is 1, we are getting a low accuracy score, which is around 55 or 50 like 45%. When it is 2, we are getting around 87 to 88%. When the value of maximum depth is 3, we are getting around 98 or 99%. And after that it remains consistent, so we can consider the least max depth value, which is 3 over here, and we can pass that as our tuning parameter. So from this we have observed and got the, and after analyzing that our value of max depth should be 3 for this model. Then the next process comes is training. So we will be training our model. sklearn.tree, we will be importing the decision tree classifier. Then let me initialize the variable as model for the training which we will be doing. And the criteria which we have learned now that we should pass over here is entropy, as it handles the data much better, and we will be considering the information gain to consider our the root value. So we should pass here criteria as entropy and not the default value, which is guinea. And the max depth which we have analyzed was 3, as we can see that we are taking over here 3, so we will be passing 3 over here. For that only, to find that only, we have plotted that, and again the randomization issue, so we will be passing the random state is equals to 0. Then we will be training our process using the dot fit function, the variable which we have initialized dot fit, and passing the independent and dependent variables of the training data set. Then our next step would be to find the prediction. So we can find that prediction using the dot predict function. So ypred is equals to model dot predict of x test. We will be passing the independent variable of the testing data set, and then we can run it. After that, we can calculate the accuracy score for it. Calculate the accuracy score, we should again we have already imported it, the accuracy score from sklearn matrix, so we can directly print it. So we can print it that the accuracy of a model we will be using dot format function to print in it. So let me print it in terms of percentage, so I'll multiply with 100 also, and then dot format function to format it. Here we should pass the accuracy score variable which we have initialized, the accuracy score, and then we should pass the y test for this, and also the ypred, which we got the actual prediction using this model, and the actual prediction which is made and already there in the data set is passed, and then also the prediction which is made using the decision tree model is passed. And after that we should multiply it with 100 to get in terms of percentage. So after that we are good to go, we can run it. So as you can see that our accuracy of model is 97.36%, which is pretty good. So our model, it predicts all the values accurately only. So let us summarize what we did over here in this model. First, we imported all the necessary libraries. Here we are importing directly the dataset online. So for that, we should include sklearn.datasets. Then we have imported the NumPy libraries and Pandas library and matplotlib to find the maximum depth value to plot the value and visualize it. Then we have loaded the dataset. Then we have using pandas library and storing our data in data frame, which is usually stored in tables. And here the data set contains 150 rows and 4 columns. Then we have initialized a y variable and printed all the target variables, which is 0, 1, and 2. 0 stands for virginica, versicolor, and setosa. Then we will be summarizing our data set using dataset dot data. It will be printing our independent variables. Dot target, it will be printing our output variables, and the shape will be printed of our independent variables, the features which we'll be considering. So here we can see that we are considering total 4 features. Yeah, so it is written over here that it is 4 columns, so we can understand that we are using 4 features. Then we are splitting our training and testing data set. For that, we are importing train, test, learn, and then we are initializing it. And then after we have plotted it for it by passing the all the accuracy scores which we are getting for different values of max depth in the range of 1 to 10. You can take more range and find, but for that also you will be getting the consistent value only. So our least max depth is taken over here, which is 3. Then we are training it by passing the criteria as entropy, and after that we are predicting the result and then finding the accuracy, which is the evaluation metric. So after that we get our accuracy as 97.36. This was all about today's session, which was on decision tree, random forest, and naive bias. Hope you enjoyed it. Thank you.